Hey again. Okay, so we're going to continue with endocrine. And so we have introduced to you the anterior pituitary and shown you how the anterior pituitary and the hypothalamus are related, how the hypothalamus will release hormones that are either inhibiting hormones or stimulating hormones. And I really want this to change colors. Okay, sorry. And so we're going to talk about, and I showed you how the hypothalamus will release inhibiting and releasing factors onto the anterior pituitary. Then the anterior pituitary will release its own set of hormones. And so we're going to focus in this video on gonadotropins and prolactin. Okay? So if you think back to that original slide, if you want to go back and look at your notes, we had the two sets of blood vessels. We had the ones from the hypothalamus and we had the ones from the anterior pituitary. I'm just kind of going to go through each one of those sections and focus on that in different videos. Each last about 10-15 minutes. All right. So luteinizing and FSH. Okay. So do you remember what caused the release of LH and FSH? Do you remember that? All right. That was going to come from the hypothalamus. Where did I go? Oh no, I went the wrong way. I'm so sorry. Okay. So this is going to be the gonadotropin, the GnRH, the gonadotropin releasing hormones from the hypothalamus. That's what causes the release of luteinizing hormone and FSH. So make sure you kind of got that that picture from our previous talk about what's coming from the hypothalamus and how that's affecting the anterior pituitary. So GnRH is going to cause the release of luteinizing hormone and follicle stimulating hormone. Now, if you had had reproductive physiology, you would go, oh, I know where this is going, but you haven't, so these words mean nothing to you. But there's something in the ovary as the egg develops called a corpus luteum. Okay, so luteum, luteinizing. So I know that this is going to target the ovary. Okay, so I know that just because I know a little bit of reproductive physiology. Follicle stimulating hormone. There's also, when you talk about the ovary, there are things called follicles. So I'm like, oh, again, I know this is going to go to the ovary. Well, they also go to the testes, okay? So because the ovary is the female version of the gonad and the testes is the male version of the gonads, and they respond to the same kind of parent hormones. They both respond to or not, I won't say parent as in your mom and dad, but as the ones that control them. They both can respond to LH and FSH. So when LH and FSH go to the ovary, okay, so travel to the blood to the ovary in the female, FSH stimulates follicle and egg development. Okay, so it causes the follicle that houses the egg to develop. It also causes the release of estrogen. And estrogen is a hormone. Okay, so that makes LH causes the ovary to release a hormone, and it releases estrogen. And so FSH allows you to get estrogen and also for the egg to develop. The LH, the luteinizing hormone, that stimulates ovulation, okay, the development of the corpus luteum, which is an important structure that you need in order to maintain a pregnancy. There's a time there when you're first pregnant that you don't have a placenta yet. And so the corpus luteum kind of acts like the placenta until the placenta gets started. You'll understand that more when we get to reproduction. It's kind of the cart before the horse. But I use these terms and I want to let you know a little bit about what that means. So the LH is going to cause you to ovulate, which is release an egg, and then to allow the corpus luteum to be developed, which will again help maintain a pregnancy. It also causes the release of hormones, and in particular progesterone, also some estrogen, but in particular progesterone. So FSH for estrogen and LH for progesterone and to some extent estrogen. Now follicle stimulating hormone and luteinizing hormone also target the testes in the male. And in the male, FSH is for sperm development. So, oh, that's nice. FSH does egg and sperm. So that's nice and handy. You can remember that. So FSH for eggs and sperm. LH is for the stimulation of testosterone secretion. So testosterone is the male hormone, estrogen, progesterone are the female hormones. So LH is for testosterone secretion in the male. So LH and FSH are considered your gonadotropins, and they're secreted by gonadotropic cells of the anterior pituitary, okay, in response of GnRH from the hypothalamus. Okay, you always got to kind of remember where that's coming from. So FSH is for gamete production, and so when I use the word gamete, I'm saying that's a fancy word for egg and sperm. Again, I know you guys haven't had repro, so I'm having to kind of give you the good word and the layperson's word and then the medical term. LH promotes the production of your gonadal hormones like progesterone, estrogen, and testosterone. You don't have these in prepubescent boys and girls. Okay, so in the blood of people who have not gone through puberty, you don't see these gonadotropins. They're going to be released at the onset of puberty. So that's one of the things that we'll talk about with reproduction. We'll talk about going through puberty, and that's going to be the release of these gonadotropins into the blood. If you have too much or too little, hyposecretion will be the failure to have sexual maturation. So you may not go through puberty. You may never have a period. You may never have eggs develop. You may not have sperm production. Okay. No real effects of hypersecretion. There's probably some, but we don't really go into some of those those rare findings, I guess you would say. So there can be hypersecretion, but you know, no bad effects. I guess I should say it that way. So the other anterior pituitary hormone, anterior pituitary, say that fast 10 times, is prolactin. I'm going to cover that now. We'll do this in a different video. All right, so prolactin, so remember you had prolactin releasing and prolactin inhibiting factors. Hope you remember that from the hypothalamus. And so prolactin inhibiting factors will inhibit the release of prolactin from the anterior pituitary. Prolactin releasing factors will stimulate the release of prolactin from the anterior pituitary. So generally, that's going to be under the control of prolactin inhibiting factors because we don't need to lactate all the time. We're not trying to make milk. But after pregnancy, you're going to get a lot of that prolactin releasing factor to stimulate prolactin so that the mammary glands will make milk. All right, so this is going to be a case where you see PRF and prolactin post-pregnancy in a lactating or nursing mother. So prolactin will target the mammary tissue, travels to the blood, to the mammary glands, and causes the mammary glands to grow and enlarge and also to form milk. So pregnant women will notice in the last trimester of their pregnancy, the last 3 months, the breasts start to enlarge and they get bigger and the mammary glands enlarge and they're ready to start making milk. Prolactin stimulates milk production, okay? It's regulated primarily by that prolactin inhibiting hormone. That's going to be the one that's mostly in control because we don't lactate most of our life. That's, you know, you're going to have that after pregnancy. Prolactin levels are going to rise toward the end of pregnancy, cause those breast tissues to engorge and grow and the mammary glands to mature and start to form, be ready to form milk so that you're ready to nurse as soon as the baby is delivered. In order for you to produce a lot of milk, a lot of times your milk, they'll say your milk doesn't come in for a couple of days. So part of the thing that kind of gets the milk turned on and really starting to turn in and make more and more milk is that suckling will cause the release of PRH from the hypothalamus. So prolactin releasing hormone is going to be released in response to suckling in those first few days, and that's really going to kind of kickstart the whole process and really promote more, I keep hitting the microphone, I'm sorry, continued milk production, okay? So the first couple of days, milk production is actually something called colostrum, and we're going to talk about that. And then your actual milk comes in. And so this is going to be real watery, not a lot of fats, and this milk is the good sugar or fat, what you think of as milk, and that's going to take a couple of days after you've had plenty of prolactin kind of coming in and getting that started. Remember, prolactin and oxytocin work together in nursing. So prolactin makes the milk, oxytocin will cause milk letdown, and they both work through positive feedback, okay? So I've got this to show you how these two hormones work together for milk production and also milk release. So you have to have a starting point. So let's just say that the stimulation is those mechanoreceptors at the end of it's on the nipple. So as the child suckles, that's going to cause those mechanoreceptors to fire and send a signal to the hypothalamus, to the brain. And then the brain is going to release prolactin releasing factors, PRF, to the anterior pituitary, which is going to secrete prolactin, which will then travel to the breast to make more milk. Okay. At the same time, that suckling will also tell the hypothalamus, hey, you've got another hormone I need in the posterior pituitary where the oxytocin is being stored. So now the oxytocin will leave the posterior pituitary and travel again to the breast, and that will cause the letdown reflex where milk is then ejected. And so this is that positive feedback loop. Okay, so it requires both prolactin and oxytocin to nurse. So oxytocin is going to be the positive feedback portion of this this nursing mechanism. Two hormones, oxytocin, prolactin, and oxytocin works through positive feedback. Okay, does that make sense? All right. Some disorders, too much, too little. Hypo would be poor milk production. Some people just cannot nurse. They don't have, that should be secretion. There should be an either. Hyposecretion would be poor milk production in nursing women. Hypersecretion, there's something called galactorrhea, which is inappropriate milk production. So maybe you're making too much or possibly making it when you're not even nursing. So there's something going on and you're making prolactin and you're not nursing. It can have an effect on your period, so you may stop having a period. And in males, because males have a pituitary just like females do, so they have the hormone, it can cause impotence. Okay, so those are some things that can happen if you have too much or too little prolactin. All right, so that's the end of today's lecture, and we will continue with more anterior pituitary hormones in a future video. Thanks again.